Hello, I'm going to be going over the exam, try and get some extra points out of it. So I'm just going to go over every question one by one. So on the first one, I actually got that one correct. The free body diagram right here for a rotating person being stuck to the wall. For the second one, I actually got wrong. Um, when you're looking at it's because of a constant speed, the tangential component of the ladybug's acceleration is actually 0. Let's see, you got number 3 right. Number 4, this one's a stupid mistake. Of course, let's see, it's going to be less than, the time is going to be less than due to the air resistance from when you throw a stone up in the air. It's going to have air resistance going up, and then it's going to have as much air resistance going down, so it's going to be actually smaller. Let's see, for number 5, I actually got that one right, so it's going to be approximately G. 6, I got that one right as well, and this is the work for it. So basically, the lighter marble, if you look at the kinetic energy, is going to be 1/2 mv squared, and then the heavier marble, since it's twice as heavy, it's going to be 1/2 2mv squared, and then when you write it all out, it basically equals 2, so you can say that has 2 times the energy. For number 7, this one took a little digging to actually figure out. So basically, the way I started it out is that you know that F equals ma. We also know that we have to look at the power, since we have to assume that the power of the engine is independent of the velocity and negligent of friction. So we're basically solving for the force. We know that all these things equal each other. So we know that the power, or force equals power over velocity. And I just substituted power as k. K is a constant that depends on the power and mass. Basically, I wrote it down as a differential equation. A equals dv over dt, and that equals kv. Basically, change it around. Have v dv on one side, k dt on the other side. You integrate both sides. Since k is a constant, you leave it be and just solve for dt. Once you're done with that, you basically get v1 squared over v2. Oh yeah, you solve the integration. You solve from 0 to v1, and from k it's 0 to t1. So basically, after the integration, you get v1 squared over 2 equals kt1. Basically, plug in the values. So we know that for velocity 1, it's going to be